Alrighty, so here we go on day 2 of quadratic transformations. So today students will be able to determine the effects on the graph of the parent function f of x equals x squared when f of x is replaced by f of x plus d, f of x minus c, and f of bx for specific values of a, b, c, and d. So in here, again, I will say let's notice some things. Notice d is on the outside, and so is a. Okay, that means it's a vertical change. C is on the inside, and so is B. That means on the inside is a horizontal change because it's with the x value. If it's adding or subtracting, it's shifting. If it's multiplying, it's compression or stretching. Okay, so quadratic function is anything with that x squared. The quadratic parent function is y equals x squared. Before we transform anything, before any transformations happen, it starts at y equals x squared. A parabola, that's the shape of a quadratic function. No, that's a parabola. X-intercepts, where it crosses the x-axis. It's also called a solution, a root, or a zero. The vertex, that very lowest point here, or it's that very highest point, that's a vertex. The axis of symmetry is the line that goes straight through the center. A maximum is when it's like a mountain. It has a maximum, a very highest point. A minimum is like a hole in the ground. It has a very lowest point, okay? We don't need quadratic formula or the discriminant today. Standard form, y equals ax squared plus bx plus c. Vertex form, y equals ax minus h squared plus k. This is mainly what we're looking at today. Okay, we don't need completing the square today. Now, I'm going to go over the worksheet you did yesterday with you. I'm going to do it without a calculator, and then I'm going to do it with the calculator, okay? So without a calculator, let's look at some things. It says the graph of h of x opens upward or downward. Well, this little negative sign tells me that. It opens downward. If you have a negative sign, it opens downward. The next part says the graph h of x will blank by a factor of blank. So this 5 tells me that. This 5 tells me that it's going to stretch, and it is 5, so it's stretching by a factor of 5. Next, the graph of h of x translated horizontally blank by blank units. So is it moving to the right or left? Well, this tells me that. Okay, remember x's are liars. It's in the room with the x, so it's not going to go to the right one. Instead, it goes to the left one. The next one says the graph h of x translated vertically blank by blank units. So that means up and down. Well, this tells me that. So is that telling me it's going to go up or is it going to go down? The negative sign says it's going to go down and go down 2 units because it's a 2. When graphed, the vertex of the graph, h of x, labeled is in what quadrant? Okay, so whenever it's graphed, it's in what quadrant? Quadrant 1, 2, 3, and 4. The way I'm going to find that is by finding the vertex. Okay, so the vertex is the opposite of this, negative 1, and then this, negative 2. So it's that. So if it's a negative and a negative, that means it's going to be in quadrant 3. Because you have to go negative and then negative. So it's in quadrant 3. Okay, next one. Give the equation of the axis of symmetry. Okay, the axis of symmetry is going to be whatever this is. So it's x equals negative 1. Next one says the graph h of x has a blank value at blank. So is it a maximum or minimum? Well, if it opens downward like we said it did, that means it goes like this. That tells me it's a maximum, so we can cross out minimums. Okay, is it going to be y equals negative 1 or y equals negative 2? Well, does the y equal negative 1 or negative 2? Negative 2. All right, so then the next spot says the domain of the function h of x is what? Well, the domain of every quadratic function is all real numbers. Every quadratic function has a domain of all real numbers. The next one says the range of the quadratic function is what? Well, we know it goes upside down. Okay, so that means y is going to be everything less than or equal to whatever number. Well, the very highest point it is this -2. So that's going to be our range. Okay, and the last point is when the graph of h of x blank intersects the x-axis. Will it not, or may not? Well, if it's upside down like this in quadrant 3, no, it's never going to cross the x-axis. So that was your paper from yesterday, doing it without a calculator. Now I'm going to show you how to do it with the calculator. So with the calculator, let me go ahead and get this screen set up here. With this calculator, in the first spot, we're going to type in x squared. So go to y equals, and we're going to put our parent function, x squared. Okay? Then down here, we're going to type in our equation. -5 parentheses x plus 1 parentheses squared minus 2. Okay? So we hit graph. Now looking at the graph, the first question wants to know, does it open upward or downward? Remember, this is the graph it came from, and this is the new graph that it is. So does it open upward or downward? Downward. Okay? Now they want to know, is it compression or stretching? Well, it's getting thinner, so it's obviously a stretch. Okay, and it's by 5. Okay? Then it wants to know, did it move to the right or the left? Well, from here it moved to the right, to the left 1. So we put that. Left 1. Then it wants to know, did it go up or down? Well, from here it went down 1, 2. So we put that. It next wants to know which quadrant it's in. So 1, 2, 3. It's obviously in quadrant 3. Now it wants to know where's the vertex. So the vertex, x first, is -1. And then down 1, 2. So -1, -2. The next one wants to know the axis of symmetry. So remember, it's that line that goes straight through the center. It goes straight through right here at -1. Now it wants to know if it has a maximum or minimum, and where is that maximum or minimum. So it goes upside down. So it has a very maximum here at y equals -2. The domain of quadratic functions are always all real numbers, but if you look, how far this way is it going to go? Forever. How far this way is it going to go? Forever. So it's all real numbers. Now we need our range. Okay, so it's upside down here at -2. So y is everything less than -2. So we need to find the one that says y is less than -2. That's y is greater than -2, less than, greater than. Okay, then it wants to know, is it going to cross the x-axis? Well, let's look at it. Is that ever going to touch this line? No way, Jose. So it will not. Okay, so that's how you're going to do all of the worksheets today, the same exact way. You can either graph it or you can show me the work on your paper. Be sure, if you do not know how to do it, you come and talk with me, ask questions, figure out how, because you will have a quiz over it tomorrow.